In this video, I'd like to have a short conversation regarding units. Consider this page. Typical textbooks will have a page similar to this one, outlining the units. Up here we have what are known as base units. So for lengths in the world of physics, we measure a length that's measured in meters. That is the base unit for lengths. For mass we use the kilogram. And for time, physics uses the second. And of course, in electricity, we have the ampere. Kelvin is the go-to temperature for science. And then there's the mole and the candela. These 7 units are known as the base units. You may look at these as the building blocks. If you were to put a combination of these together, we would get what known as derived units. So combining some of these together, let's take the meter, the kilogram, and the second. If they were combined together, and if we look down here in the derived units, here's a combination of kilograms, meters, and seconds. We'll just get a closer view of that. And this combination of kilogram, meters, and seconds is also called a Newton, named after Sir Isaac Newton. So these are known as the derived units. We have the base units, the basic building blocks, right here. For lengths is the meters, the kilogram, the seconds. Combine them in various different orders, and we have these derived units, as you see here. Let's do an example of units. So consider the number 6. If I were to say to you, or someone were to say to you, go to the grocery store and buy 6. The first thing that you would ask is, okay, I'm going to go to the grocery store, but buy 6 what? And the answer would be 6 apples. Well, apples is the unit. Apples describes the number 6. Units don't have to be the kilograms, the meters, and the seconds, as long as it describes the number preceding it, or following it, I should say. It is a unit. Consider, go to the grocery store and buy 6 pounds of potatoes. The 6 pounds of potatoes, even though it's a little phrase, this is the unit. Why is it the unit? Because it describes the number 6. Consider, go to the grocery store and buy 6 packs of spearmint gum. Again, this little phrase describes the number 6. So units describe the number preceding them. Now we can take this a little bit further, again with the number 6. Go into the world of chemistry, 6 grams of sodium chloride. Now chemistry likes to use grams, where in physics, for mass, we use kilograms. Nevertheless, this is the unit that describes the number 6. Or consider 6 moles of carbon. Again, this describes the number 6. And in the world of physics, if we were talking lengths, it'll be 6 meters using the base units. Now the base units in the world of physics are these. If for lengths, it would be the meter. For mass, it would be the kilogram, and time is the second. So staying in the base units, 6 kilograms and 6 seconds. M represents meters. kg, as you already know, is the kilogram. And S is for seconds. In physics, the base unit is the second. Not minutes, not hours. We use seconds. And so why do we use units? Well, units describes the number. All of these have the number 6, but they all mean different things because they all have different units. Let's go a step further now and work with the units. Consider this example. And I'm working with the units right now. Work with units. Say that we have a length. I measured something from here to here, and that length happens to be, I'll go and measure it, 2 meters long. Remember, m represents meters when it's used as a unit. And I'm going to add to it, take another length after it, and this length right here now is 3 meters. The summation of these two, 2 meters plus 3 meters, 2 meters, all numbers in the world of science have units attached to them. In pure mathematics, it doesn't, but in science, we have units. 2 meters plus 3 meters is equal to, we add the two numbers together, 5. Because this is only a plus sign, as long as the units match, we can go ahead and then just carry the units. 5 meters. That distance then is 5 meters. Back in basic mathematics, we used to use x's. For instance, 2x. These are variables. The x is a variable, whereas the m here is a unit. 2x plus 3x is equal to, same rules apply. Add the two numbers together, 5. And as long as the variables are the same, you can just go ahead and add the two together and carry the x. So it becomes 5x. Now consider an area. Yeah, we have a little, I'm going to draw a box here. And consider the length of this area is 3 meters. And the height of this area, the width of this area is 2 meters. And I want to find what the area is here. The equation for an area for this rectangle is equal to the length times the width. Now let's look at that. Let's put in the numbers here for length and width. So the area is equal to, well, the length is 3 meters times the width of 2 meters. And this one is times now. Now up here we did addition. We're talking multiplication. 3 times 2 is the area of this rectangle. And that comes to, multiply the two numbers together. 3 times the 2 is 6. But now we also have to multiply the meters, the units. Multiply the units together. And it becomes, I'm going to do this the long way. It meters, and the little dot represents multiplication. Meters times the meters. That meter times this meter. Now we don't generally write it like this. But these units, they operate just like numbers. They have powers to them. A little power of 1. And if I were to go back in basic math, x to the power of 1 times x to the power of 1 is equal to, well, the units are, the bases are the same, so it's x, and you just add the powers, 1 plus 1. X times x is equal to x squared. Units operate the same way. So meters to the power of 1 and meters to the power of 1. Meters times meters then is equal to 6. Add the powers together, 1 plus 1 is 2, 6 meters squared. So this area then, working with the units, is 6 meters squared. Consider one more example. This is Sir Isaac Newton's second law of motion, where he writes the force is equal to mass times acceleration. Mass times acceleration. Now we're interested in the units, not so much the numbers. So force is equal to, and the unit for mass, the base unit for mass, is the kilogram. So we'll just write down, without the numbers, we'll just write down the units because we're interested only in the units. Units for mass is the kilogram. And the units for acceleration, we're going to multiply. Units for acceleration is, in base units, it's the meters per second squared. That will be the unit for acceleration. For a car that's accelerating down the road at 20 meters per second squared, it's rather fast, so 2 meters per second squared type thing. but we're only interested in the units. So force is equal to kilogram meters per second squared. This combination of units, they don't cancel out. We can't multiply them together. We can't divide them. They have to stay like this. And it becomes cumbersome to always say, okay, force in the units of kilogram meters per second squared. So what has been done, is that combination of units has been given a different name, the Newton, after Sir Isaac Newton. This is his second law of motion. So a combination of kilogram meters per second squared, these are the base units, has been given the name of a Newton, and now it becomes what's called a derived unit. So these derived units is a combination of the basic units up here. These are the building blocks, and this is what we are building with them. So it becomes a Newton. So this combination is also known as a Newton. And because this is an equality, that means force must also have the units of Newton, because whatever's on the left-hand side has to be equal what's on the right-hand side, and that applies to units. So force, and we'll do Newton's second law of motion later on. Force has the units of newtons, is equal to whatever the value is here, and I'm just going to rewrite mass times acceleration. Mass times the acceleration. Here's my short form for acceleration. And this has the unit of Newton. As a result, the newtons on the left-hand side is equal to the newtons on the right-hand side. The units on the left-hand side have to equal the units on the right-hand side. Otherwise, it won't be an equation. And this is a short conversation on units. The base units and the derived units.